right? What if we had a function which was equal to the integral of another function? So p of x, that means that we have to have an x variable over here, and that's where it's located, in the upper bound, right? So p of x is a function which is defined by the integral of f of t dt. And the reason why we have t here and here is because we've already used x as a variable, so we need another variable, and the secondary variable tends to be t, but this could have been any other letter besides p or f or x right here. So the graph of f we see over here, just a basic two line segments, one with a positive slope, one with a negative slope. And p is the integral from 0 to x of this function. And we are asked to fill out this table. We're asked to find some values for p. Right? So I know the first blank is underneath when x is -1. However, I'm actually going to start with when x is 0. And you'll see why in a second. So if x is 0, that means we're interested in, let me get this on the screen here, p of 0. All right, so p of 0, that means that we have a 0 here, which means we would put a 0 in for all values of x. Well, the only other value of x is right there. So we're going to put a 0 in for the top bound, right there. This 0 is already squared away, all right? And then we have f of t dt. Okay, so p of 0 is equal to all the area under the curve of f, because we know the definite integral means we're looking at the area between the function and the x-axis. So we want all the area between f and the x-axis starting at 0 and ending at 0, which means we basically want that area right there. Well, that area is one-dimensional. It has no area. There's that region. It has no area at all. And we know this because one of our properties of definite integrals is that when the upper bound and the lower bound are the same value, that means that the integral will be equal to 0. So we can put a 0 in right here. All right, let's go to 1. If we want p of 1, well, that's going to be the integral from 0 to 1 now. Because, again, we're putting a 1 here, which means we want to put a 1 right there. All right, so we want the integral from 0 to 1 of f of t dt, which means we want all of the area between the function and the x-axis starting from 0 and going to 1. So here's 0, here's 1, so we're looking at this region right here, which I'm going to turn orange. All right, what's the area of that region? Well, there's a couple ways of going about this. And those of you with the geometric minds are looking at this and saying, okay, well, we've got 1 block, 2 blocks, and then we have a half a block. So that's 2.5. And that would be correct. Another way of looking at it is this is a trapezoid. One base is 2, the other base is 3. The sum of them is 5. The height is 1, and we want half of that. That's another way to get 2.5. So we've now accumulated some area. This orange region right here, hence the reason why these are called accumulation functions. Remember, we're going to accumulate some more area now. So we're going to look at p of 2. So that's the integral from 0 to 2 of f of t dt, because again, we're putting the 2 here, which means we have to put it there. So we're going to accumulate some more area, which I'm going to color pink. We're going to go from 0 all the way to 2, which means that we now have the orange and the pink zones to combine together. Now we know the orange is 2.5, and this pink zone is a little bit less than that because we can see that we cross down here at 1.5. All right, so if we do a quick area of a trapezoid here, the height of the first base is 3, but the second base is only 1.5. So we have 3 plus 1.5. That's the sum of our bases. The height is still 1 unit, and then of course we want 1/2 of that according to the area of a trapezoid. So we have 3 plus 1.5, which is 4.5, and we want half of 4.5. All right, so that would be 2.25. So the pink region is 2.25. The orange region is 2.5. We're going to add them up together because we've accumulated, we're going from 0 all the way to 2, so it's orange and pink. And that means we have 2.5 plus the 2.25, or 4.75. All right, now let's go to p of 3, because we got a couple more to go. P of 3 is the integral from 0 to 3 of f of t dt. All right, so let's bring in another color. We're going to go green this time. So we're going to get all the way up to that point right there. So I think it's easiest to find this. Now let's put the neon green and the pink together. We have one big triangle. All right, so that's a height of 3 and a base of 2, so that's 6, and 6, half of that would be 3, so we have 3 for this area, we have 2.5 for the orange area. For the total area is going to be 5.5. And finally, P of 4, well, that's the integral from 0 to 4 of f of t dt. And that's this region. I'll just shade this in red here. That's this region right here. Now, that region is a triangle. That's an area, base of 1, height of 1, so that's an area of 1/2. All right. But what do we know about this region right here? It's below the x-axis, exactly. So what does that do to our area? Yeah, we got to subtract it. So we're going to have 5.5 minus 1/2, which drops us back down to 5. And now that we've done these, let's go back to p of -1. So p of -1 means we put a -1 where the x is, right there. And this should bother us as an integral because we see that the smaller number is up in the upper bound. We want it down in the lower bound. So we need to swap these and go from -1 to 0 of f of t dt. And we're allowed to swap the bounds, but what's the change that we must make in addition? Exactly, we have to negate this. All right, so we're going to take the area from -1 to 0. All right, so -1 to 0 is this blue region right here. All right, and that region, again, we can see real quickly is 1.5. It's a brick and a half there. So that's 1.5, but it is negative. So we're going to have -1.5 right there. That's the region from -1 to 0. So we've now filled out the chart. Okay. So I'm going to make another quick video in which we fill out the Q chart as well. But I'd actually, if this is making sense for you, what I'd like you to do right now is before you watch the second video, see if you can fill out this chart. All right, notice that the integral begins at -1, so it might make some sense to start with that column right there, work your way to the right, and then go back and do the previous two. But you can absolutely start here if you'd prefer. But see if you can fill in this chart in the same manner that we filled in this chart, all right, by finding the area between the function and the x-axis. And again, if you're able to do that without me, then click on the next video, but fast forward towards the end point and see if your answers agree with mine. And then the next video, we'll talk about the connections that we're looking to make.